checking that these blocks are embedded inside of blocks of the proof of stake chain.
Got it. So there'll be this merge block that will mark this transition.
Yeah.
And over time, I guess the new chain will contain the full record of all the transactions that's ever happened on the previous chain, on the old chain. So like maybe I'm asking a dumb question here, but in this process, is the new chain going to have all the information of the past transactions?
The new chain is not going to hold information from what happened in the Ethereum chain before the merge, right? So like Ethereum clients of the that people are going to use like around the time of the merge and soon after the merge, they're probably just going to sync and check the proof of work chain up to the merge, and then they're going to check the proof of stake chain. But at some point in the future, I think people will just stop bothering checking the proof of work before the merge.
Got it. So that old history information is not important for the future. Or like if you're operating actively on the new chain, that history is not important to you.
It's not important. Let's see. So it's not strictly important for just like in any like smart contract or just like applications that run on the blockchain. It can be important to users, and it can be important for some applications. But we're basically saying that like maintaining and serving that is not going to be simultaneously the responsibility of every Ethereum node. If you want that information, there can be separate protocols for backing it up. And like these other protocols actually exist, right? Like there's something called the Graph, which is doing some history retrieval. Potentially, you can just take that entire chain and stake it on BitTorrent. Like there's lots of ways to like archive it and create kind of customized search protocols for it.
So what's your sense why... so there's a Python 2 and Python 3, and it took forever for people to switch. What's your sense why this merge has been taking longer than perhaps was expected?
I think the biggest reason is just we've been underestimating the technical complexity. There's a lot of technical complexity in making a successful proof of stake chain. There's a lot of technical complexity in actually figuring out the transition process.
So that's bigger than social complexity. So it's the technical complexity, you would say, is the bigger reason for any delays than the social complexity.
I actually think so. I think we've been very fortunate to not have too much social complexity around the merge.
So not much drama.
No. I think the biggest part of the reason is just because we have been talking about proof of stake and sharding as being part of the roadmap since almost the very beginning of the project, right? Yes. Like the very first proof of stake blog post is from January 2014, which was 2 months after the project started, and like maybe even a day after the announcement. So it was proof of stake was not something that we kind of put on anybody by surprise. And then when the DAO fork happened and the people on the ETC side split off, I think it also just happens that a lot of the people that were not willing to stomach the DAO fork and then join the ETC side, they were the more Bitcoiny types, and the more Bitcoiny types do also tends to like proof of work more. And so like that also sort of ended up, sort of like purifying the communities on both sides, I guess. So Ethereum Classic is not switching to proof of stake, and they're happy with their setup. And by the time that it came to the Beacon chain launching and now, I think the community is very strongly in favor of the proof of stake switch.
But let me ask the question that no engineer wants to hear, which is the question of timeline. When do you think the merge will happen? Do you have a sense it might happen this year? Do you have a sense it might be pushed towards next year, 2022, or even beyond?
I think early 2022 is the most realistic. There's definitely still like an optimistic case of it happening this year, but like the realistic thing to count on is definitely the early part of very early part of next year.
Is there specific things that stand out to you that are like they'll make you feel good about progress if you see it happening?
So the thing that we had last month is we had this online hackathon called Rayonism, where basically a bunch of the different client developers that are going to be part of the transition like hacked together some test nets of the post-merge Ethereum chain. So these were only test nets of what would happen after the merge. They were not test nets of the transition itself.
Mm-hmm.
So the thing that people are working on now actually is the transition. So having a full specification of both the transition and post-transition. I mean, we have specifications now, but like, realistically, they'll probably needs to have a couple of changes and have things that continue to be ironed out, and then have a test net that does both the transition and the post-transition. And then, like, once you have a test network, then you just have to do a lot of testing and audit it, and then do some runs on not just a specialized test network, but on, say, an existing test network like Ropsten or Rinkeby that Ethereum people already significantly use. And if it works, then you can deploy the transition on mainnet.
Just as a quick comment, because this is fascinating, in August of last year, there was this Madala.
I believe it's pronounced Medasha. It's a South American subway station. I forget where.
But spelled with two L's.
Yeah, because that's that's how Spanish works, right? Like the two L's have
Madasha.
Yeah.
Okay, cool. Anyway, but I read about it in middle of August 14th. There was an incident on that test net. How does this process work? Like, what do you learn from those kinds of incidents when stuff goes wrong in the test process?
I think that incident was that there was a consensus failure of some kind, as I remember. Like basically just different clients interpreting things in different ways, and then one of them getting kicked off the network. And then it had ended up taking a while to actually like get everyone to get back online. Like a big part of the reason why it took weeks to resolve, right, is because it's on a test network, like the coins are valueless. And so there's not really this big push of any kind for people to actually, go and download a new client so they can start participating again. Mm-hmm. And so, it definitely took a while until the chain started finalizing again. And then also, like, there was, I think, another round of just not finalizing in October, as I remember. There were definitely things that we learned. Like there were a lot of things, especially that client developers just learned about, like optimization and how to build their clients in a way that they can process things efficiently. There's a lot that we learned from just like seeing the full life cycle of what happens when more than a third of the validators go offline and then finalization stops. And then that kind of weird, unusual state of the chain continues for a while, and then eventually everyone who is not participating just gets enough of their stake. Like we don't use the word slashed, we use the word leaked for this, but like basically also burned until the people who are participating go back up to 2/3, and then the chain goes back to finalizing. So just seeing all of those edge cases play out live, I think actually helped a lot, and probably helped to really contribute to making us feel better about mainnet.
I mean, there's also an incident just recently in April 24th of 2021 where this was on Beacon, I guess. There was a bug discovered in the software client Prism that prevented roughly 70% of validators on the network from producing blocks. I mean, maybe you can comment on what happened, but broadly, like the big picture, what kind of stuff are you worried about in terms of problems that might arise? Are we talking about small bugs? Are we talking about like emergent unexpected social bugs? What are the things that worry you about the future of Ethereum that you want to make sure you construct mechanisms that prevent those things from happening?
So one of the lucky things there was that this particular bug only prevented proposals of blocks. It did not prevent attestations, right? So attestations is just a mechanism for voting on blocks. And it's the attestations that are actually responsible for the chain finalizing. So like coming to this more permanent agreement on blocks, right? So the chain was actually quite stable all the way through. I think the thing that we generally learn from these experiences is just how valuable it is to have this multi-client network, right? So this is one of these areas where I think Ethereum distinguishes itself from like Bitcoin, for example, right? That in Ethereum, we don't have one single client that everyone just runs, right? There's multiple implementations of the protocol, and these multiple implementations, they all process and verify the blocks that each other can, verify, right? So they all speak the same language. Now, sometimes when there's a bug, they disagree, right? And when two clients disagree because of a bug, we call this a consensus failure. And consensus failures are pretty serious, right? And when you have client monoculture like Bitcoin does, then it's more rare to have consensus failures. Though you still have them, actually. Bitcoin had a consensus failure between two different versions of the same client back in 2013. But they're less likely to happen. But the interesting thing is that the multi-client architecture has actually, I think, saved Ethereum much more than it's hurt it. So even in this most recent incident, right, like Prism was not producing blocks, but all the other clients were still producing blocks.
There's 4 others, right?
Yes, it's Prism, Nimbus, Teku, and the Lighthouse. And then also Ethereum back in 2016 had this fun event that we call the Shanghai DOS attacks. They're called that because the attacks started right on the first day of our annual conference at DEF CON that happens to be in Shanghai that year.
Mm-hmm.
So what happened basically was that someone came up with a way to create blocks that were very slow for one client to process, but not the other client. So at that time, there were basically 2 Ethereum clients. They were called Geth and Parity. Right now, I think the top 3 ones are Geth, Nethermind, and Besu. But what happened as a result of us having 2 clients is that the attacker was just not able to come up with blocks that both clients were completely failing at processing. And so a lot of the miners and a lot of the network participants, they just kept on switching between the 2 implementations depending on which one worked. And that actually really helped the chain kind of survive through that month of attacks as the attacker just kept on hammering at our system and identifying all of the weaknesses and just forcing our clients to do this rapid sprint of just optimizing the hell out of everything and make sure there aren't any of those DOS blocks or and DOS bugs remaining. So that was another example. And then as a counter example, so something that also shows the point from the other side. Bitcoin had this bug in 2010, right? The balance overflow bug. Basically, someone created a transaction that had 2 outputs, and those outputs were both of a few billion Bitcoin, so about 2 to the power of 63 satoshis. Mm-hmm. And then if you add those numbers together, you go above 2 to the power of 64. And of course, computers once you go above 2 to the power of 64, you wrap around. And so the Bitcoin nodes thought that there was enough money to pay for the transaction because it was asking for, let's say, a billion satoshis or something, but actually it was asking for 2 to the power of 64 plus a billion. And so, the attacker just managed to create billions of Bitcoin out of thin air. And this was not only discovered and fixed after something like 12 hours. But if there had been, if Bitcoin had been a multiple implementation system, then what would have almost certainly happened is one of the clients would have bugged out, but the other clients would have probably actually had a check for that, right? And so there would have been a consensus failure, but at least that would have alerted everyone that there is a problem very quickly, and it also would have given everyone just obvious social permission to go and pick whichever one of the chains is correct and solve the problem. So that's, I think, a big learning that we've had from multiple of our experiences in the Ethereum ecosystem, just validating this multi-client model. And to be fair, it's a model that we get criticized for a lot, right? Bitcoin people talk about, the risk of consensus failures that this creates. VC types are well, isn't it expensive and wasteful to fund 3 software teams when you could just be making, one quote focused effort? They love the word focused, and Ethereum is not that, but it's amazing despite not being that.
Yeah.
Basically, yeah. So that was interesting, and then there have definitely been other learnings as well, just from seeing the chain live and seeing what actually is the staking experience what are the actual incentives for all the different participants. So I definitely feel we're gaining a lot from this sort of 1 year of trial running the chain before we actually make all of Ethereum depend on it.
Let me ask perhaps a strange question, but proponents of Bitcoin will say things like Bitcoin fixes everything.
Hmm.
So why do we need Ethereum versus like Bitcoin plus Lightning Network for
Mhm.
scalability, and then using Bitcoin with this proof of work for security? So in this kind of it is perhaps sort of a strange question, but it's a high level question. Why do we need another technology? Yes, it has a bunch of nice features, but like, doesn't Bitcoin fix everything already?
So, and the thing that always attracted me about Bitcoin is, these values of, decentralization, creating these open permissionless systems that anyone can participate in and that aren't just going to flop over and die if whoever created them gets bored, and like, that are resistant to like whoever runs them breaking the rules and all of these things, right? And I think that pretty strongly that these principles are like really valid and important to much more things than just money, right? Like Bitcoin is the blockchain for money, and Ethereum is built from the start as a general purpose blockchain, right? It's there is Ether, the asset on Ethereum, but then you can also make decentralized financial things, what we call DeFi today. You can make like ENS, the decentralized domain name system. You can make prediction markets on it. You can make totally non-financial systems that just like keep track of whether or not some certificate was signed or whether or not some like cryptographic key got revoked. There's this big long list of like just interesting things that you could use about blockchains to do, right? Like basically, they are sort of the missing piece that where without them, the kinds of things that a decentralized computer network can do is very limited. And once you have them, a lot of those limitations end up going away. And so Ethereum was like always from the beginning about that, right? It's about like, hey, this isn't just money. There's so much more that you could do if you could just go ahead and make any infrastructure or digital institution or DAO or whatever you want to call it, where the kind of the base layer of the logic is just executed in this open and transparent way where everyone can see what's going on. Or, if you like your zero knowledge proofs, at least everyone can see proofs that prove to you that what's going on follows the rules. And you don't need to like just constantly keep trusting centralized actors. And
Hence the smart contracts
exactly.
as being a sort of a core technology as part of Ethereum.
Yes, exactly. Smart contracts, the computer programs that are running on Ethereum, they are like the core of what makes Ethereum general purpose.
Yeah.
So I do think that, there's a lot more that wrong with the world than just money, right? Like I'm not one of these people who thinks that, if you get rid of fiat currency and you replace it with cryptocurrency, then suddenly wars are going to go away, right? Because like, first of all, like seigniorage revenue is only a small portion of government revenue, right? It's like what, 5-10%, something like that. Second of all, like if you are the sort of this is one of the things I don't even get about their philosophy. Like, let's say you're the sort of person who is an extreme and very distrusting libertarian, and you think that these governments are terrible, right? Like we know today that governments fund a combination of things like welfare and things like the military that goes and like bombs people in Afghanistan, right? And the question you have to ask is like, okay, you with your new, magic newfangled cyber currency that takes over the world, take away the government's ability to have seigniorage revenue, and so you reduce the government's revenue by 10%. If the government is that evil, which portion of its expenses is it going to take that 10% from? Is it going to stop the bombing people in Afghanistan, or is it going to cut welfare? If you think it's the first, you have a very optimistic view of the government, right?
Yeah.
So that's, I guess, my perspective on like why the whole we're going to save the world and create peace by like denying governments the right to stealth taxation kind of perspective doesn't really make much sense for me. And I do think that there is real value that comes from a decentralized and open currency, like just the fact that there is a financial infrastructure that anyone in the world can go ahead and use, right? Like it's that's something that can easily be a big boon for people, right? There's a lot of places where the currency is much less stable than the dollar, and these people, like, they don't, like, well, if they use Bitcoin, their only option is to get Bitcoins, right? Which, are also pretty volatile. If they use Ethereum, then, they can get Ether, but then they can also get stable coins, right? And you might think that, oh, you're not being ideologically pure. Now you're giving them stable coins, which are mirroring dollars, and obviously dollars are going to collapse too. But the reality is that dollars are vastly more stable than the Venezuelan bolivar. So, like, there are really meaningful and beneficial things that you can give to people by having a global and open financial system. But I think if you want to actually do that, like, you have to have much more than just a currency, right? And then if you want to go beyond financial things, then, you have to obviously have much more than a currency. And then, you also have to actually take scalability seriously, because non-financial applications, like, nobody's going to pay $5 a transaction for them.
Can we return to dogs?
Sure.
No.
The other one's categorically forbidden?
Yeah, categorically forbidden. Is there any cryptocurrency based on cats, actually?
I think there are. Like, there was Catcoin, there was Nancoin. For some reason, they just didn't catch on as much as the dog coins did.
Okay, so let's talk about Dogecoin and Elon Musk. Elon said that, quote, ideally, Doge speeds up block time 10x, increases block size 10x, and drops fee 100x. Then it wins hands down, end quote. You said in a blog post, partially responding to that there are subtle technical reasons why this is not possible. To this, Elon said that you, quote, fear the Doge. So let's talk about this. What are the technical hurdles for Dogecoin that prevent it from becoming one of the primary cryptocurrencies of the world? And do you, in fact, fear the Doge?
I definitely feel obligated to correct the record. I definitely do not fear the Doge.
Okay.
I love the Doge. I actually visited the Doge in Japan a few years back. It's she's an amazing dog. She's still alive.
Wait, the original Doge?
Yeah.
Oh, wow.
So, we accept Doge every year for our annual DEF CON conferences. So, I definitely, don't think Ethereum is opposed to dog coins. I kind of want to feel like, Ethereum is at least a little bit in spirit itself a dog coin. And then, as I mentioned, I love Doge. I bought a bunch of Doge. I still hold a bunch of Doge. On the scalability question, like, the challenge basically is like the limits to scalability and the trade-offs with centralization, right? Like, if you just increase the parameters without doing anything else, then it just becomes more and more difficult for people to validate the chain, and it just becomes more likely that the chain becomes centralized and becomes vulnerable to all kinds of capture.
Mm-hmm. So does it need like some of the layer 2 technologies that we've been talking about?
I personally think that, if Doge wants to somehow bridge to Ethereum and then people can trade Doge thousands of times a second inside of Loopring, then, that would be amazing. If they want to just like take ZK rollup style technology and just have thousands of transactions a second on their own chain, then that's, that would be a great outcome as well.
So what, is there ways for Ethereum and Dogecoin to work together? So, okay, so there's a power behind a person like Elon Musk pushing the development of a cryptocurrency. Mm-hmm. Is there ways to leverage that power and that momentum to improve Ethereum, to improve some of the sort of cryptocurrencies that are already technologically advanced and pushing forward that kind of technology?
I definitely think there's room for...
that there's that meme of Doge like taking over, like that storm.
Yes, I've seen it.
Is there a way to ride that that storm, that wave of the Doge that's taking over?
I think if we can have a secure Doge to Ethereum bridge, then that would be amazing. And then when Ethereum gets its scalability, any scalability thing that works for Ethereum assets, you would be able to also like trade wrapped Doge with extremely low transaction fees and very high speed as well.
Is there precedence for building secure bridges between cryptocurrencies? Is there? I mean, how difficult is this kind of task?
It's definitely something that's in its infancy. There definitely have been some cross-chain interaction things that have been done before. The earliest is probably the concept of merge mining, right? When a chain just makes its entire proof of work algorithm dependent on the proof of work algorithm of another chain. Right, so I think famous Dogecoin actually merge mines to Litecoin, which is, I think, in retrospect, not looking like a very good choice because now Dogecoin is bigger than Litecoin. But if there's potentially some way for Dogecoin to merge mine with an Ethereum proof of stake of some kinds, then like that could be an interesting alternative. If So that's one type of like chain interaction. As far as like bridges, like one chain reading another chain, early in Ethereum's history, there was this project called BTC Relay. It's a smart contract on Ethereum that just verifies Bitcoin blocks. I think people stopped really caring about and maintaining it because there just weren't enough applications that were actually interested in using it at the time, and the transaction fees got too high to actually maintain it. So I think if we want to make a BTC Relay 2.0 and that becomes cheaper because it uses snarks or something like that, then you probably could. And maybe now's the time when you actually can do that sort of one-way verification. But the one challenge, though, is that if you want to have a bridge that allows you to move assets between chains, then you don't just need one-way verification, you need two-way verification, right? And Ethereum can verify anything because Ethereum smart contracts can just run arbitrary code. But if you want Bitcoin to be able to do things based on what happens in Ethereum lands, then Bitcoin would have to basically, they can do everything with soft forks because that's their religion, but they'll do it that way. And if Doge wants to make a fork where that allows for two-way transferability with Ethereum, then they could. I mean, I think that would be a lovely collaboration to make if there's interest. I think there might actually even be some multi-sig funds that has some funding. It's just a bounty for someone to make a bridge between the two.
Oh. Could you maybe try to psychoanalyze Elon Musk for a brief second? So what are your thoughts about Tesla and Elon Musk's journey through the cryptocurrency world? So first with Bitcoin and then with Dogecoin. So holding a large amount of Bitcoin. And I believe, at least considering the acquiring and holding a large amount of Dogecoin. Positives, negatives. What do you think the future for Tesla and SpaceX in the cryptocurrency space looks like? Do you think they'll consider Ethereum?
I'm sure that if they stay in the cryptocurrency ecosystem at all, then they have to at some point. Right?
Yeah.
Bitcoin number one, Dogecoin number. I mean, come on, it deserves to be number 3, and then or number 2, and then Ethereum can be whatever that other number is.
If Ethereum only becomes a dog coin somehow, maybe change the logo to incorporate a dog of some sort, almost like Doge, sneaking behind.
Oh, that would be fascinating.
When the merge happens.
And I think Elon, you definitely, I think you would make a mistake if you were to kind of ascribe too much sophisticated malevolent or any deep intentionality to the whole process. I think he's just a human being and he likes dogs just like I like dogs.
Yeah,
right?
I think that is literally the reasoning behind the whole Dogecoin thing. There's some aspect to which, I mean, the guy helped launch a car into space, right? You could ask what is the purpose of that? I think the purpose of that is fun. I think he truly is more and more, especially lately, embodying the whole idea that the most entertaining outcome is the most likely, and he's fully embracing the most entertaining outcome. And in many ways, Dogecoin is the most entertaining cryptocurrency. As cryptocurrency becomes more and more impactful in the world, people are getting more and more serious about it. And so he's selecting the cryptocurrency that is the least serious and the most fun. And there's something to that, coupling fun with technological sophistication, and somehow figuring out a way to do that.
Absolutely.
To do that well.
And I want the world to be fun. I think the world being fun is great.
Okay, let me ask about a couple out of the technologies, if it's okay.
Sure.
What are your thoughts about Chainlink and hybrid smart contracts that utilize off-chain external data sources?
And I think it's definitely necessary for smart contracts so that do a lot of things to use off-chain data of some kind, right? Like if you want to have a stable coin, you need a price oracle so you know what price you're targeting. If you want to have some fancy, crop insurance gadget, like I think EtherRisk has been doing a lot of good work with that. I think it was either Kenya or Sri Lanka or both. Like they're making a lot of good progress in some of those places. Like you need some kind of oracle to tell you, did it actually rain in this particular area? If you want to have like assets that mirror other financial assets, you need an oracle. If you want to have a prediction market, you need an oracle. And so projects that provide oracles are definitely really important. There are definitely different kinds of use cases. Like Augur is more about events, and the Augur Oracle is designed, like I think, differently from Chainlink, right? Like Chainlink emphasizes the whole, like we have a fast automated thing that just like gives you data quickly. Whereas Augur is more, we don't give a crap about speed. And look, we don't need to give a crap about speed because if you want to get your money out on a prediction market that where in reality it's resolved, you can probably just sell your coins for 99 cents anyway. So I think Chainlink is definitely like taking a good and like important part of the Oracle design space, and I'm definitely happy that there's like that project taking the task on. At the same time, I do think that their frog army on Twitter can get a bit intense at times. But
the frog army, is there a way to incorporate sort of Oracle network type of ideas into Ethereum?
I personally would prefer the Ethereum base layer. Like, stay away from trying to provide too much functionality because, like, once you have the Ethereum base layer making a claim about, like, say, the US dollar to Ethereum price, like, and at some sense, you're basically saying that like Ethereum as a base platform starts making what could be geopolitical statements, right? Like for example, imagine if there was some, civil war and the U.S. split up and you had two currencies that both claims to be the U.S. dollar. Well, Ethereum would have to pick one for the sake of everyone who's already using that oracle. So, does that mean that the blockchain would be like taking a position in this big mega political debate? So I think, like for just those kinds of reasons, I would personally prefer Ethereum itself to be more of this sort of pure platform that just analyzes transactions just mathematically using deterministic consensus rules. And then if you need the oracles, that can be layer twos. I think Ethereum benefits from not trying to do everything at layer one and having this like very robust layer two ecosystem where you have all these projects doing interesting things.
Yeah, focus on the basic technology, avoid the politics. Gotcha. Let me ask a bit of a human question. Charles Hoskinson, someone you've worked with in the early days of Ethereum, there appears, to my outsider view, to have been a bit of a falling out. Is there a positive, inspiring human story to be told about why you two parted ways?
I kind of want to let the various books about Ethereum speak for themselves. But I feel like, since that time, I think, Charles has clearly progressed and matured in a lot of ways. And people who follow Charles closely have definitely told me that, like 2021 Charles is very different from 2014 Charles. And I'm sure 2021 Vitalik is much different from 2014 Vitalik as well.
I'm kind of interested how the 2030 and 2040 Vitalik and Charles look like as well.
Interesting.
like the progression of the humans.
Is this going to be one of those things where like everyone comes full circle and then 2030 Vitalik and Charles are best friends?
Yeah. Not necessarily best friends, but some kind of are able to reminisce in ways that is that puts some of the tension of the past behind.
I think such things are possible. I think people definitely absolutely have a right to, and I think should strive to just constantly change and reinvent themselves.
Is there something you could say about your thoughts about the Cardano project that Charles Hoskinson leads, they worked on some interesting ideas that mirror some of the ideas in Ethereum, proof of stake, working on smart contracts and all those kinds of things. Is there something, again, positive, inspiring that you could say? Are they a competitor? Is it a complementary technology?
It's and there's definitely interesting ideas in there. I mean, I do think Cardano takes a bit of a different approach than Ethereum in that, they really emphasize having these big academic proofs for everything. Whereas Ethereum tends to be more okay with heuristic arguments, and in part because it's just trying to do more faster. But there's definitely very interesting things that come out of IOHK research. So,
can you comment on that kind of idea? I, as sort of having a foot in research, enjoy Charles's kind of emphasis on papers and like deep academic rigor. What's the role of deep research rigor in the world of cryptocurrency?
Interesting. I'm actually the sort of person who thinks deep rigor is overrated. The reason why I think deep rigor is overrated is because I think like the in terms of like why protocols fail, I think the number of failures that are outside the model is even more important, is like bigger and more important than the failures that are inside the model. Right. So like if you take selfish mining, for example, like that original discovery from 2013 that showed how Bitcoin does, like, even if it has a 50% fault tolerance, assuming everyone's honest, it only has a 0 to 33% fault tolerance depending on your network model if you assume rational actors. And like to me, that was a great example of like an outside the model failure, right? Because traditional consensus research, just up until or before the blockchain days, did not think about like incentivization much, right? Like there was a little bit of thought about incentivization. There's like a couple of papers on the Byzantine altruist rational model, but it wasn't that deep. It was mostly operating under the assumption that we're going to make consensus between 15 participants, and these are institutions. And if something goes wrong, then, if it was, we can figure out whether or not it was deliberate offline. And if they did something evil, we can sue them. Whereas, in the crypto world, you can't do that, right? And so, like, that whole discovery basically arose just because, like, the model of traditional consensus research just like didn't cover those possibilities. And then once you go out of that model, those other issues do exist, right? But then at the same time, like there definitely are protocols that turn out to be that do have failures inside the model. Like this reminds me of the time when I think I found a bug in a proposed consensus implementation from either BitShares or EOS. This happened around the end of 2017. So that was definitely inside the model because like they had a very clear idea of what they were trying to achieve. They had a very clear description, and like there's a very clear mathematical argument for why the description doesn't lead to what they're trying to achieve. But like ultimately, what you're trying to achieve can never be fully described in formal language, right? Like I think this is the big discovery of the AI safety people, for example, right? Like just having a specification of what you want is an insanely hard problem. And like the more powerful the optimizer that you're giving the instructions to, the more you have to be careful. And so, I think there are kind of these two sides. And then the other thing is that a lot of the academic approach ends up like basically optimizing for other people inside of the academic system. Right. And it doesn't really optimize for like curious outsiders. Whereas like I personally, Matt, like totally optimize for curious outsiders, or at least I feel like I strive to. So I guess like that's my case for why I like tends to behave in ways that occasionally traditional academic types criticize as being reckless. But on the other hand, there's definitely real benefits that come from like just taking a rigorous approach, especially when what the thing that what the specification is of what you're trying to get, and like you're trying to kind of improve your way or provide protocols that actually provide that, and like exactly what you're looking for. I feel like realistically, you probably wants to do both kinds of analysis. And like sometimes you even want to do both kinds of analysis in stages, right? Like you want to do more quick and dirty things, and you even want public feedback on the quick and dirty stuff, and then later on you formalize it more, and then you get more feedback. Like in general, I guess I feel like the norms of research in the future, like the internet has just changed so much. There's no way that it's not going, and it's even changed like collaboration structures and like the patterns in which we work with each other. There's no way that the correct structure for collaborative research is the same as what it was 15 years ago. But like, what combination of these existing components and of new ideas it is, like that's something that's totally legitimate to kind of fight it out. And I think it's great that there's different ecosystems that have different attitudes to things. Like I think there's a big possibility that things that the Ethereum ways that the Ethereum ecosystem approaches some problems is totally wrong. And if there's other ecosystems with different principles and they do well, that's something that we can learn from.
In the spirit of the depth first search, can you comment on AI safety? And some people are really worried about the existential risks of artificial intelligence. Is there something you could say that's hopeful about how we avoid, in the same kind of line of reasoning about creating formal models versus kind of looking outside the model into what the real world actually is like? Is there some lessons from that we can take and map onto the AI safety world, where the potentials of the technology, whether it's in autonomous weapon systems or just the paperclip problem, that we can avoid AI destroying the world?
So my impression is actually that this is more of a kind of faraway impression, and it could be wrong, that it might even be that one of the challenges is that AI is not formal enough. Like, because AI is very like practitioner oriented, right? Like it's all about like, hey, I found a couple of hacks and look, I ran them and look, they seem to improve classification accuracy from 0.684 to 0.773.
Yep.
So a lot of the time, like there just isn't actual science behind like why this hack works and why this other hack doesn't work. You just sort of like trial and error your way into it. And like I could see how that approach works, but at the same time, like that approach is not good for legibility, for example. Like it's not good for like understanding what the heck is actually going on, like how these kinds of systems conceivably might fail. Like there's even, a debate on like, can you take GPT-3 like things and just scale them up and their intelligence will continue to improve? Or is there just like some types of reasoning that they're fundamentally bad at, and like they're not going to get good at it no matter how much you like scale this exact same approach and add more hardware to it? So thinking about what's going on more explicitly, I mean, my understanding is that a big part of AI safety research is trying to do that sort of stuff, right? And
formalize,
try to improve just AI legibility, like trying to understand, if the AI makes some classification so we can actually see like what happens and like what's going on in the middle, right? Whereas with crypto or with traditional cryptography, it's like very much not, well, okay, I mean, I should quite say that. It's traditional cryptography is this interesting mix of being very formal and being very informal, because it's very formal with, given these security assumptions, prove that the protocol works under these security assumptions.
Yeah.
The places where it's very informal is like, well, how do we even know that there isn't an efficient algorithm for factoring numbers? Yeah, we kind of tried it for 40 years, and then, so far no one's found anything better than the general number field sieve, and like, okay, fine, we'll just assume it's fine. How do we know you can't find the discrete log between two elliptic curve points? Like, no. Did it a couple of decades. No one's found anything faster than like baby step, giant step stuff. So that's, and like there's definitely ways in which that approach really makes sense, right? Because at least you can concentrate your analysis on a small number of building blocks. And like, you do have some intuitive reasoning about those building blocks, but like at least there's a small number of building blocks and lots of people are looking at them. And then everything else just sort of gets formally built on top, and you actually can like mathematically reduce the security of big things to building blocks, right? Like you can have mathematical proofs that say, if you make a zk-SNARK of a statement when in reality that statement is false, then you can use that to like extract information out of elliptic curves that it completely breaks the problem or something like that. So
ZK Snark is an example where formalism is beneficial.
Absolutely, yeah.
And so maybe you can have the same kind of stuff in the AI safety within AI systems, that you can get a hold of some kind of aspect of the systems that you can control,
right?
Provably.
Yeah. And then in blockchains and cryptocurrency, I think the one area where consensus mechanisms is still more an art than a science is that these aren't just technological systems; they're crypto-economic systems, right? And they make assumptions about people, and which assumptions you can make about people is not something that you can prove with math.
Right. Even just the basic 51%.
Exactly.
People are honest.
Yeah. Can you trust the 51%? If you can't trust the 51%, can you trust the other 49% to be able to coordinate on making their own fork? What will happen to coin prices? How do people as human beings react to these events? There's all of these assumptions.
Yeah.
But at the same time, look, if you can write down the assumptions, then you can do formal things with them.
I almost forgot to ask you about one of the most exciting aspects of Ethereum. I mean, it's non-technical. I think it's a societal, it's social, which is NFTs. So, what do you think? What do you think about the explosion of NFTs in the recent months, especially in the art world and beyond? And what does the future look like? So this is maybe the social impact on the world, on the individual creators of all kinds. Is